Hello, today we are going to try to fix this server rack mount uninterruptible power supply. It is a quite interesting unit because if you take a look at my channel, I've got a very similar design with totally different company. So I've got feeling that that panel, that case is like a generic Chinese stuff. It exploded with a loud bang and lot of magic smoke. As you can see, I already removed the top part, and between that was like a overmount, and that's because I was ordering spare part. Let's take a look at the back. So we've got our standard filter for phone line, we've got the USB for control, we've got AC input and the multiple outputs. It was made by company Energenie, but as I told you, I expect it is like a more generic stuff that was just imported by the company, and we've got the information it is in the Netherlands, but we've got the made in China, 900 watts. We've got a 24 volt setup with 2 batteries in series. I very enjoy that. That board looks extremely simple, so I'm pretty sure that that's going to be not a true sine wave. We would not have any filters. We just got a extremely beefy transformer over there. And to the center tap, we've got our positive pole. And then we've got our like H bridge created of those transistors, those MOSFETs. That one is playing a different role because it's got a insulation. Those are definitely on the DC side because we've got those beefy cable and they are going to be inverting our DC and feeding to the transformer through the transformer, and that's going to be our AC part with a charging tab. We've got bunch of relays and microcontroller. Here you can see what's released the magic smoke. So that was those 3 MOSFETs. That one got a hole, that one is cracked open, and here I can see a small break. And the explosion was so violent that the pieces go there. And they ended up over here. You can see a spot with the charcoal. So the idea is that I'm planning to remove this board. I check out the part number, I order replacement, and they just arrive. And we are going to try to put them, except of those marks that are going to be easy to clean. I do not see more damage. I'm wondering what's going to reveal after we go and remove that board and we see upside down. And let's do a peekaboo. We've got a lot of traces, some tiny SMD components, but it don't look bad. It looks actually very nice. I'm looking around those sections and I do not see much damage. Of course, I've got the battery unplugged from the beginning. I'm just going to tell you that I'm not risking touching and poking around. And let's try to undo those 3. And let's do my favorite part, which is removing the solder. For best results, I'm always wiggling it around, and that is causing our part to get loose. And as you can see, this is how our part looks like. On the other one, we should be able to see the die. So let's give it a moment. Let's remove the broken leg. It doesn't look very good, but we are going to clean that up. Let's go with other legs. Okay, looks beautiful. And as you can see, can we see die and judge if that was genuine part? Looks like it was pretty big, so maybe that was genuine one. Here is how it was looking. And as you can see, that one is also crack open. So we had a pretty massive force. Let's take a look at them. What's interesting, we've got fuses over there, like a car style, but they are not broken. I would say that I can accept it as clean, and we can mount the replacements. So let me find our magic bag and pull 3 elements. Let me bend the center leg nicely, and we are going to stuff them in. Here I will do the opposite. I will put a screw first, and that's because I need to get exactly the correct length, because if I do it wrong, then the screw won't match to the heatsink. Of course, I'm just checking if the device is working. I'm going to apply the thermal paste if it's ended up to be operational. And we are going to be very nicely soldering them. We are going to create a nice big blob because they rely on a lot of current. Those want the control, so they don't need to be beefy. But that one, yes. And how does it present? It looks pretty good. The one on the other side looks great, and we can remove them, but yeah, let's try it out. Let's just see if it's going to be working. at all. Because if we'll break, then I've got 3 more to do another try. I really don't know what to expect from that device. We are going to be not using the battery, we are going to be using lab power supply, and I'm going to be limiting current. Let's clean up here. We need to plug our front panel. It goes like this. And we've got our 2 connectors. First go there. And here we've got the LCD. Just like that. Looks absolutely beautiful. And now we are going to be able to see that we've got a success. And let's attach the lab power supply. Since I'm going to be using power supply and there is extremely small chance of iron explosion, but I'm still going to put my safety glasses. We are going to grab our negative and we are going to be hooking up here. So let's make sure that it is properly insulated and a short like this. And we are going to be clipping to the positive, and let's take a look. Are we going to get some boom boom? The power supply read 0 current. Absolutely nothing. So let's try to start the inverter. I hear a good sound. It's booting up. It turned itself off, but I'm pretty sure that's because of the power supply. It's not enough to demand the full current. Let me try to restart it. It was pulling 2.5 amp. So I think that we are going to get a success. I've got feeling that we are going to get success. Let me use a real battery. I rig up those 2 12-volt batteries connected in series. I'm pretty sure that you are wondering why I've got this like that, and I'm just creating a shield in case it's go toward me. So it is for a reason, but you can pick from that camera. And we are going to try to enable it and see what's going to happen. And everything is working fine. We've got a 220 volts at the output, battery charge in 91%, 0 load, the frequency 50 Hz. We've got the information that we are working in the emergency mode. We should silence it by pressing that button. And we are in the silence mode. As you can see, my true RMS meter is telling me that we've got a proper voltage, 226 volt, which is totally okay. And looks like we've got a good success. So I'm going to add the thermal paste. That was like 50% of success, because we've got absolutely no idea what's going to happen if we are going to plug the AC. We have to first check, do we have a charging current into the battery, because it is too early to say that we've got everything under control. Let's see, do we've got charging into our battery. And yes, I can see the current flowing toward the battery, so it is a really good sign. On battery, I read 26.5, it's jumped to 6, so it's definitely recharging our battery. Let's see what's going to happen when I disconnect the AC. Is it going to go into the inverter mode? And let's do that right now. It go into the emergency. I can hear the inverter working. And looks like we've got a good fix. This is the battery that was mounted inside. As you can see, it's branded with the same company that manufactured that UPS, so it is a quite interesting touch. It was OEM. It was 8 amp hour at 20 hour, so it is not a very good battery, because we should grab the one that is going to be rated at the 15-minute discharge for the UPS use. But yeah, I'm pretty sure we are going to get a great success with this device. For you, it was 1 second. For me, waiting for delivery. And we've got a replacement from company called CSB. This is like a long-lasting series, extremely good quality. And as you can see, it is rated in 15-minute discharge cycle. And that's make it absolutely the best use case for uninterruptible power supplies that are using high current. And that's because if you are going to purchase battery that is rated in a 20-hour discharge, then most likely the capacity is going to be much less. If you are going to be trying to pull that power in like a 15-minute or 30-minute, then the capacity at least is going to be cut in half. So you are paying like for a 4 amp hour battery. But if you connect it to the dummy load and discharge for 20 hours, yes, it will deliver that. So you have to be extra careful. Also, I would like to show you that I didn't forget, and I add the thermal paste under those MOSFETs. So that part is over. And we are going to mount our new battery, and we are going to make a test. Since that bar is made out of metal, I tape the terminal because I don't want to short circuit it while inserting. We go like this, and we are going to grab our second battery. Welding those terminals into that metal bracket would create a serious fire hazard, so we definitely don't want to do that. So spend that 1 or 2 seconds nicely taping it, because it's definitely worth not to burn down your place. And it's going to be absolutely beautiful fix. That uninterruptible power supply is going to be protecting my video editing setup. So I decided to purchase absolutely the top tier batteries. I didn't go for the cheapest one, but for the best and long lasting. Our batteries are in place. We can remove our protective tape. We are going to be starting from creating the interconnecting shorts. We are going to grab our positive, where goes here. That's going to be our positive plus 30 volts. And let's measure what they read straight from the factory. We go like this. We've got a 12.5 volts. The second one, about the same, and together 25 volt. Great, it should start right away. Here is a small tip: if you are working on device and waiting like a month to get spare part, then grab a small bag and put all your screw, tie them into something inside, and you are not going to lose them. Very good tip. Everything is in place, thermal paste is inside, and it's going to be ready for mounting back. So let's grab our negative pole and connect it, just like that. And we can try if it's going to be running. It booted up and the inverter is working. We can silence the alarm and everything looks good. So let me turn it off and put everything back. Power supply is ready for our final test. So let's take a look at the bag. Here are our outputs and we are going to try to plug something in. So I'm going to be using that adapter that is going to give us a French socket from the computer style. So we go like this, and here we will be able to plug our appliance. And I will also provide AC power. So we go like this. Right now there is no AC present. So let me rotate it. So we are going to be nicely seeing what's going on. Here we are going to grab my vintage lamp, just like that. And it's going to be plugged in into that French socket. And let's turn on our device from battery. The lamp is working, and on the display we've got all parameters ready. And everything is good to go. We can try to plug our AC in, and we are going to see whether it's going to be transferred back to main. And I'm plugging it in right now. We hear a click of a relay. I can hear the inverter stop working. We had a tiny blink and we are back. We are recharging our battery. As you can see, the percents are going up. Let's take a look if it's going to be transferred back. So now I'm going to simulate the power outage. I'm just going to pull the cord and everything is working fine. We've got our alarm and the system is working. So as you are able to see, with replacing bunch of exploded transistors, replacing the battery, we managed to get absolutely beautiful fix. So thank you very much for watching. I hope you find it interesting. See you next time and bye bye.